Hello, good morning, afternoon, or evening, based upon where you are joining us from. And welcome to this important discussion arranged by Policy Research Institute for South Asia, PRISA as we call it. I am Dr. Muhammad Nadeem Sarwar. I am the Director Research South Asian Integration at PRISA. Today's topic is air pollution in South Asia, especially in terms of its consequences and possible prevention strategies from the regional perspective. According to the World Bank, 9 out of world's 10 cities with the worst air pollution are in South Asia. This leads to millions of premature deaths. While South Asian countries share these challenges, geopolitical tensions and the lack of funding hamper their ability to cooperate and address this pressing issue. In context of region's wider susceptibility to climate risk, this paints a worrying picture for its people. We are fortunate today to be joined by 4 members of APAD Air Pollution Asset Level Detection, which investigates the sources of air pollution in South Asia and Africa, allowing the team to identify, quantify, and analyze these sources for the benefit of researchers and policymakers. The format of today's talk will be as follows. I will introduce a speaker and the person will have 10 minutes to talk on the topic of the webinar. After which I will introduce the next speaker who will again have the 10 minutes to talk. And once we have gone through all of our 4 speakers, we will have around 20 to 30 minutes for Q&A from the audience. So I would request all of you to please hold those until the end. So with this, let me introduce you to our first speaker. So we are today joined as first speaker by Mr. Hassan Aftab Sheikh. Mr. Hassan is a career development fellow at natural finance at Smith School of Geography and Environment, University of Oxford, as well as founding member of APAD. He holds a PhD in Earth Sciences from the University of Cambridge. His research focuses on nature, climate change, air pollution, and finance. With these, I give this stage to Mr. Hassan, and we are keen to hear from him.
Think Hassan couldn't join. Uh, I don't see him in the meeting here, but um, so on behalf of the team, I would like to we cannot give his introduction, but we will tell you about briefly what APAD is and and how we start and how we've started, how we came to being, and then later on, the rest of us would explain. Um, what we do and what's the research focused on and what are the products. So AirPad basically started last year with seed funding from the Smith School of Geography from Oxford. And then later we were supported by AWS. So the main idea revolves around clean air being the basic right of human, and especially in parts where like Africa and South Asia, where we have this problem of air pollution, and it's substantially because of poor policy making, and then the control and the measures that are taken in terms of regulating those asset level sources is something to question and something that needs a lot of research on. And also so what we focus on is we try to identify those sources, and then how we can from a bottom up or top down approach, we are open to different approaches and to see how we can quantify those asset level sources and the quantification of the emissions across. And we target non-stream, or the non the pollutants that are not actually studied in the mainstream research. Or for example, many people focus on carbon dioxide and then greenhouse gases, methane, but then there are other toxin pollutants like PM, particulate matter, SO2, and oxides of nitrogen that are also huge contributor to the air pollution, but then they are not readily discussed in research. So those are things that we focus on. And then um, and yeah, so that being said, we will try and bring to your focus to what APAD is doing in taking those measures, and extending our work and what we've been doing so far. Can you move to the next slide, Iman, please? So that being said, one of the important component, and most of our team members, I think we heavily rely on what we call geospatial sciences, and then machine learning, deep learning, geospatial analysis, GIS. So all of these are the important tools which we use and utilize for the development of our products, and all the things that we invite all of you to visit our website and our dashboard as well, where we have hosted and published different data set that we've produced, and data set that we have added value to, and we've hosted them on our websites. So the most important component, or the most important player, in all of that, is the satellite imagery. Because as you know, that many of the places that we are discussing today about South Asia or Africa, those are very hard, very remote to access. And then it's practically difficult. No, I won't say impossible, but very difficult for you to go down there and then count those assets individually. So for to cater that, I think satellite imagery is an important and a tool that's being used in a lot of research nowadays. So then we've decided to take advantage of that as well. So as many of you know, some of you might have an experience in working with satellite imagery, or you've come across in from different perspectives. So it actually offers an observation, a historical observation of the whole Earth, and then it's very consistent, very reliable in many ways to a certain extent, and also gives you access to wide area of information, which is not possible when you go physically down for surveys and stuff. And why do we use it, and what is the benefit for AirPad, is that using satellite imagery, we can do asset detection, especially the industrial assets like coal plants, cement plants, paper and pulp, brick kilns. So we will discuss further, during our presentation, during this webinar, that what we are focusing on, and then also the use of satellite imagery for the detection of vehicle. Um, Going a step further, we once we have the assets, then we can use different satellite products. I think many of you might not know, but there are Sentinel products, this Sentinel constellation, which are used not only to get natural images of the Earth, but also different products like pollution product from Sentinel 3, 5. Um, so that also helps you estimate the air pollution around. And the benefit of satellite imagery is that it doesn't limit you, and it doesn't it actually helps you scale your products, scale your models. So that's a huge benefit that we have, that huge advantage that we have taken from it. And again, given that it offers consistent information and data, it helps you do near real time get information. Next. So, as we were just discussing, and it's a good natural transition. As we were discussing about Sentinel products, so Sentinel offers an open access Earth monitoring. As you can see, um, this picture sort of highlights or takes you back to how pollutant the South Asian territory, especially this Indo-Gangetic plain, is. That's the main focus of our group is. And you can see the red color, the hot colors highlighting that how much of a of bad quality air we breathe and our loved ones breathe almost every day. And then that's the main motivation or the instrument of inspiration for us, that we are focusing our work on this area and trying to uh, get as more and make information accessible to as many personnel as possible so that they can take the right measures. Talking about Sentinel being one of the important multispectral satellite imagery for us, that helps you sort of access the whole world, but also a lot of data is available in the region that we are focused on, and it's openly available. So it's something, for example, to begin your research on or to start your work, when you're just starting, it's a good product to explore and then see if you can scale your models, scale your products up. And I was briefly talking about Sentinel 5P that helps you, that is actually designed to obtain information about the pollutants, aerosols, and all the toxins that are in the atmosphere at, at a reasonable resolution. What are the important advantage is it's free, you have the global coverage, and you have a very frequent and regular coverage for Sentinel products. Next. So and for us as well, Suleiman and Iman would talk further on that. But then this is another product that we have explored, and all the products that we've been mentioning today are the ones that we have explored or we are in the process of exploring. So coming down from Sentinel to Google Static, it's a leap. It's a great leap in terms of resolution. What we were looking at, it's 10 meter and 20 meters, and then now we have come down to 1 meter resolution using Google Static Map. And that's been instrumental in one of our recent publications and also one of our recent projects of brick detection that we have used our model on. We've trained our model on initially on Sentinel. Suleiman will talk further, but the limitations of this Google Static is that we have limited metadata information that cannot be scaled to um, other products or other applications. And then the less information on spectral data, like only the information is available in RGB or the natural image, which can be a drawback in terms of when we talk about detection or extension of application. Next. As we move forward, this is something that we are exploring right now. And then it's again, as you can see, progressively we are improving the spatial resolution and also the temporal resolution of the data that we use. Now, Worldview and SkySat is, in essence, not an open source data that not everyone can access. So you get either you have to purchase it, or you get special research access permission from ESA and whoever is the distributor of this data. So this being so high with a high resolution, the aim is that either we improve our models in those acid detection, be it the chimneys of cement plant, coal plant, on or the brick kilns. Also, we are trying to expand our work on to make to bring in the vehicle detection. And we have done some research. There are so many research out there, and then we are trying to scale this for our area of interest, so that not only the industrial assets are important contributor, but the vehicle being a highly populated area, we have a lot of vehicles going around, and they contribute a lot as well. So this is one of the could be a game changer in terms of research if we can get more access to it, and then we can improve our models to work on that. Next. Now, coming down from what acid brings and how we can understand their dispersion or their emissions. So this is, I think, a very old model or a concept that was developed by NOAA. And I think the recent implementation is R in R makes it simpler, because there are so many ways to see the trajectory or the dispersion of pollutant from a point source. And then there are a lot of parameters and assumptions that goes into this model. I'm also not 100% aware of the all the nitty-gritty details of the model, but then on a higher level, I know that for a point source, knowing the information about the pollutant you want to understand or study, and the information about your point source asset, you can understand and plot the dispersion of it. So this simple plot is done using split R library in R, which uses the meteorological data from again from NOAA, and then it takes into account the temperature, all the meteorological information, also the wind information, to sort of got an understanding of like how um, this like for example, in this example, we are discussing about particulate PM10. So how it's been dispersed across for for a time period of 24 hours. You can customize it, you can parameterize it, and see what your understanding is. In the next slide, you would see a small animation where you can see the progression, the dispersion of pollutant from a point source. Can you do next? Yeah. So as you can see, this being the point source, and then how the particle is dispersing, over time, it might be overestimation and over exaggeration as well. But in essence, this is how much it can get dispersed. So again, these are things that you improve over time, and then you as the more you learn, the more you improve. So this might be an estimation, but then it gives you an idea that how from a point source over 24 hours, or if you estimate for more time, how the dispersion happens. And it gives you an understanding. It gives something for the people to realize how much is happening because of these point sources, and what measures we can take. Next, I think, yeah, over to Suleman.
Hazel, thank you so much for your insightful presentation. And let me introduce you to the audience as well. So please, sorry for that. Hazel is a geospatial analyst with APAD. His focus is on helping people to understand how sources of air pollution impact the air that is breathed daily. And thank you again for introducing us with APAD and the kind of the work that you are doing. This is really amazing, especially the presentation of the data in such a form which makes it quite easier to understand. And I hope your novel approach will also help uh, further researchers on this topic, and will also help us developing our understanding of the issue further. With this, let me move to our second speaker. Our second speaker is Suleman Hamdani, the machine learning lead at APAD project. Salman is interested in how they can turn raw data into insights that help them to understand and respond to environmental challenges. With this, over to Salman.
Thank you so much for having us again. So what I will be focusing on is how we used AI to detect break-ins across the IGP region, which includes a large part of Pakistan, Bangladesh, and some part of India. So yeah, so we have essentially, as Khizr mentioned, satellite imagery is a huge part of what we do at APAD. And going through the entire satellite imagery by our own, which is probably like millions of images, right, for the entire IGP region, that isn't practical for humans. Either you need a lot of labor, and again, it will be very time consuming. So instead, we're using satellite imagery and combining it with AI to detect break-ins. Next, Ivan. Right. So when we started, we started looking at break-ins, right? So we realized there's a huge amount of break-ins, and our estimates were around 60 to 70,000 in the IGP region. And again, as I mentioned earlier, it would not have been feasible for us to go through the entire imagery manually and then uh, pinpoint them manually, right? So this is about 1.5 million square kilometers of land. So where do you begin? You have this huge task in front of you. How are you going to tackle it? So this obviously starts with gathering data, Iman. So, as Khizr mentioned earlier, we have used multiple sources of satellite imagery. For our pipeline, we have combined low resolution satellite imagery with high resolution satellite imagery. And essentially, we combine the two pipelines together to come up with these geolocated break-ins. So for low resolution, we've used Sentinel-2, and for high resolution, we've used Google's API to get imagery from what you essentially see on Google Maps, let's say. Obviously, that is sourced by Google through multiple third parties, which includes Maxars, Worldview, and Airbus and stuff. So yeah, but we have combined Sentinel-2 and the imagery from Google Maps. Next. Right. So we first started off with Sentinel-2 imagery because this is low resolution and free and has a very frequent and it has a very frequent coverage, right? So we started off with this because, well, this is a lot cheaper than high resolution imagery. So as you can see on the slide, we trained a random forest algorithm, which is a pixel-based classification model. And this essentially looks at a satellite imagery and identifies where the break-in exactly is. So in the imagery, you'll see on the left, that's the Sentinel imagery of somewhere in Pakistan. I'm not entirely sure, but this is a break-in in Pakistan. This is the a slightly red spot that you see on the left side of the imagery towards the upper left quadrant. That is how a brickkin looks like from a low resolution imagery. It isn't as clear, it isn't as obvious, but that distinct red that you see is what identifies a brickkin. And again, we gave our model a lot of data for this, for it to learn how a brick-in looks like, and then eventually it churns out this image that you see on the right. The image on the right includes everything else that is not brick-in as black, and the red part identifies the brick-in. So yeah, but this came at a cost though. The since the only thing we're looking at is essentially the red color, even though it's pretty distinct and like it's very obvious to see. But there are other objects which might look similar since we can't see in granular details the break-in, right? So this pipeline was the baseline for detecting break-ins, and we did identify a lot of points in this which were potential break-ins, not exactly break-ins, but we realized that our model is very good at detecting all the break-ins, but it's giving a lot of false positives. So there was a need to reduce these false positives. Next slide. Right. This is again in more detail about how a brick-in looks like in Sentinel-2 imagery. You can see the on the right side, you can see the red spots. These are brick-ins, and on the left, this is what our model returned, and then we identified these centroids. Next. Right. So coming back for the need for high resolution and why our pipeline was just a baseline and not the actual pipeline. So our model, this random forest that we trained on Sentinel-2, the low resolution imagery, identified a total of 31,000 break-ins. And we know for a fact that this number is too big for Pakistan. This is just for Pakistan, by the way. We identified 31,000 break-ins in Pakistan, and we knew that there's definitely a lot of false positives. And we also realized this while our model was running for the entire Pakistani region. So this is why we realized that it is important to identify the true positives, that is the break-ins. And for that, we needed more spatial resolution, and that is only coming from high resolution imagery. Next. Right, so then we looked into different high resolution imageries, and Google's API was the cheapest amongst all of this. So we used Google's API. It's called Maps Static API, if anyone's wondering. And you can essentially use that, give it a certain point, and then it will extract the imagery of that coordinate that you gave it. So the 31,000 points that we had identified, we took all of those, and now instead of going through the entire region for high resolution imagery, which would have been incredibly costly, because now just for Pakistan, that's around 500,000 square kilometers. So that's a lot of imagery. Instead, what we did was that we took that baseline model, we took those 31,000 points that had churned out, and then we used those points exactly to uh, pick these break-ins out. So we again we started with training this high resolution imagery data. The model that we've used is YOLO V8. It's an object detection model and essentially outputs bounding boxes across around these break-ins. So as you can see, this imagery is pretty clear, and it's a lot easier for the model to identify what a break-in looks like, because there's multiple things going on here. There's the shape, there's the color, and then there's the chimney itself, right? You can see all of those. And the shape itself is very specific, which helps a lot in developing the model. So our model had amazing results on this. This had around 97% mean average precision at 50%. So obviously this was working great for us. And out of those 31,000 points, we had around 19,000 false positives, and our second model eventually detected 12,000 break-ins here in Pakistan's IGP region specifically. So yeah, that was about it. And also we then replicated this exact approach for Bangladesh and India as well. So we have detected over 50,000 break-ins in the entire IGP region. And I think that's about it. And that was just for the break-in pipeline. We are now moving towards the vehicular detection using satellite imagery, and Iman is going to take lead on that.
Thank you, Suleman. I will give me a second.
Uh, Thank you, Suleman. Just give me a minute to introduce you, and then you can come for your presentation, please. So, thank you, Suleman, again for underscoring the importance of technology, analytics, and detecting hotspot, which are really helpful. And I sincerely hope that the governments in South Asia and other parts do make use of such technological insights and make spot on decisions. With this, let me introduce to our final speaker, who is Iman Fatima, again, a machine learning analyst at APED. She is helping to identify traffic-related pollution hotspots across South Asia and Africa. So with this brief introduction, over to you.
Thank you so much for that introduction. Yeah. So now we're turning to another major source of air pollution in South Asia, which is vehicular emissions, as already mentioned. Unlike in the stationary industrial sources such as break-ins that were previously mentioned, vehicle-based emissions are dynamic in a way that they vary per hour and within short distances. So, yet they do, of course, account for a significant and a growing share of urban air pollution in cities like Lahore, Karachi, Delhi, and Dhaka, and a lot more. So, our team at APAD, we began by using a very straightforward setup, building off of our break-in pipeline. We initially used Google static maps imagery, which was paired with a method called slicing aided hyperinference. Now, this approach allowed us to zoom in on a very high traffic zones and to detect individual vehicles in high resolution map images. So the way that SAHI works is by dividing large images into much smaller overlapping tiles. This essentially enables more accurate detection of small objects like vehicles and vans and cars. So, and this is of course done in very dense environments, as you can view in the sample images shown on the slide. We use the YOLO V11 architecture for this, and it performed quite well in identifying the small vehicles. However, this approach had a very critical limitation in terms of having no temporal data. Now, these static images are just essentially snapshots. They would tell us about the locations of the vehicles, but only at a single instant. Google static maps do have a very high spatial resolution, but they lack any temporal metadata because the API returns images without any timestamps. So it's impossible to track changes over time to analyze any temporal variations in the traffic density. But of course, for analyzing vehicular pollution, we do need that kind of data because to track a vehicle density, this has to be done over time and not just space. Through support from ESA, the European Space Agency, we gained access to high resolution imagery, both in terms of space and time, from the SkySat and WorldView products. Now, SkySat provides approximately 50 centimeter spatial resolution, and it can revisit the same spots up to 12 times a day for certain regions, whereas WorldView has a 30 centimeter spatial resolution. Now, to put this into perspective, what this essentially means is that a 50 centimeter resolution would indicate that a 50 centimeters on the ground is represented by a single pixel. This essentially allows us to detect individual vehicles much more efficiently. Of course, now the access to this high resolution imagery has helped us build um, uh, a temporal vehicle density maps, which we are currently working on by adapting our slicing window approach to a different architecture, through which we will be able to analyze temporal patterns in vehicle movements and generate density maps from the satellite data. Now, of course, these insights will have very strong implications for emission zoning. Moving forward, while we do have satellite data mapping various assets, initially break-ins, vehicle data, and now moving on, we will have other assets. But what we're introducing currently is an APAD mobile app, which will be launching next week. So this app can be used by any one of you to contribute to asset mapping by just having it downloaded on your mobile app, on your mobile device, you can easily upload or take a picture on the spot. And the picture could be of any illegal dump, any burning pile of trash, or any unregulated industrial activity. Now, the what the app does is that it tags the user's coordinates with the photo, which is reported on our public dashboard, which is available at our website. So it allows you to track infrastructures such as coal, steel, plants, solid waste sites, and a lot of other assets, which will then appear on our dashboard as you can view here. Here, just a few of the assets are highlighted, but to have a better and a more precise look, you can visit our dashboard and view all of these assets. To put this to provide more quantitative perspective on all of this, Khizr can talk about the specific numbers that we have generated for some of these assets.
Yeah, so for Brickins, especially for IGP, our model has detected more than 50,000 Brickins in IGP region in Africa. So we have used different data sources. It's not just the model because you can do only enough with the models. So we have used multiple data sources, be it different other sites like Global Energy Monitor, SF Initiative, SFI Initiative, or Google Map Extractor. So these are some of the ways and sources that we have used, and we've collected this total number in both area of focus for us, IGP and Africa. So as you can see, the numbers are significantly higher in IGP, being that a bit more researched area region compared to Africa, which is still, not a lot of people do this kind of research in those areas. And that's, I think that's one of the reasons or motivation behind, extending our work to there, and then finding out about, these different assets. So these are only some of the asset types that we focused up until now, but then there are open waste sites and vehicles through our model and open waste site through our app that we are hoping to, build a strong database so that, we can bring and share the information with the rest of, the community. Next. Is
So thank you, Iman and Khizr, and especially Iman, thank you for highlighting this important work done by you. Going at such a micro level, vehicle level, is really a key benefit of technology and analytics. And by doing so, the policymakers and decision makers can, of course, use this information to make very spot on kind of the decisions. So thank you for this. And fortunately, Mr. Hassan Aftab Sheikh has also joined us. So I would like to invite him to share about APAD and his views on the topic, after which we shall go for a question and answer session. So over to you.
Thank you so much. And apologies, I was slightly late to join the meeting. I can see people have already raised some questions, and questions were on specifically the topic being regional consequences and preventive strategies. So I'll just touch upon that, and I'll invite everyone to have whatever questions they have. Since this was a very data-heavy presentation, I would kind of give a more general overview on the consequences this air pollution specifically has on Pakistan and the wider IGP region. Considering air pollution is a year-around problem for Pakistan, and what we do see is that in severe air pollution episodes around the winter, start of winter, and autumn period, we do see hospitals have a sharp rise in pollution levels. We do see illnesses come out, specifically respiratory, issues, and lots of people are then admitted, which strains Pakistan's, burdened healthcare system. So of course, air pollution has consequences not just on health, but it goes beyond, our daily life, in terms of, the impact it can potentially have on the cognitive ability or the brain development of, a 5-year-old kid going to a school, and being exposed to air that is hazardous. And this is not something that's being measured, or there's been research going on in Pakistan, and this is a large gap from whatever we understand on the consequences is from studies that have been done in the global north. And we have made, we're not able to establish causation as such, but of course there are correlations on the poor air quality reducing efficiency at work and reducing, or weakening the cognitive function, right? So I mean, the next the next steps could be looking into, diving deeper into what should be done. How can we collaborate with epidemiologists, with people who work at this intersection of health and air pollution? Because just doing,
Hassan,
yeah,
Hassan, can you just allow me for an interruption? I'm sorry about it. But
yeah,
if this you are not using these slides, can you please remove those so that we can have a bigger picture of you and all other speakers? Thank you.
thank you. So yeah, I mean, there are other consequences. So I'm only going to touch on consequences. And another thing that probably, I don't know if that was mentioned initially by Khizr, are the social inequalities that exist. Again, there's very little work that is done in Pakistan on, one, how does indoor air pollution impacts women and children particularly, considering that a lot of the time people spend is indoors. 80 to 90% of the time, even you and me, we spend indoors, whether it's in your office, it's in your classroom, it's in your home. And then we are exposed to both indoor air pollution and the interaction we have with outdoor air. So again, that's, there are studies where, people have looked into how toddlers or women specifically are at greater risk of respiratory infections from, specifically from indoor air pollution. And in terms of what can be done, there are specific interventions that should be taken by, Pakistan's government, or the broader IGP region, which does include cross-border collaboration in terms of reducing the air pollution and improving the air quality. One of the ways that can be done is that, you know, China and India, and I think Bangladesh as well, have a net zero plan by 2050. They've pledged to be net zero by 2050. Pakistan has not done anything like that. So there are emissions, non-greenhouse gas emissions that are co-currently related with your greenhouse gas emissions, which can be reduced. Again, in transport sector, we have a lot of data in terms of fuel quality and the impact of private vehicle use. So of course, reducing that, it's a very basic step, and improving your mass transit systems. But one thing which I would like to focus on is the crop residue burning season. And what happens every year is that, people have an outrage on the farmers, on when they burn, the residue, crop residue. But the answer is not to put them in jails or put large fines on them. Of course, that could be done if there are alternatives to preventing that. But because Pakistan, or even in India, there are very little alternatives for farmers. They are, then forced to just do, just burn crop residue because of intensive agriculture and crop rotation, multiple crop rotations that happen in a year. So there are studies. I don't know if you guys have come across, a study that was done at Princeton, which did highlight the pre-burning and post-burning interventions that can happen, and they differ around how you can have both administrative and measures, and also providing subsidies for agricultural machinery to reduce burden on farmers when they're dealing with crop residue. And in terms of waste, we what we are presenting is an option, like a citizen science option, because air pollution is a temporally sensitive and spatially sensitive problem. And what we don't have is people who randomly burn, the waste or any other residue in urban areas or even in rural areas. So having more data on that, and then having regulatory action on unregulated air pollution sites, again, that's a probable preventive strategy that can come in. So I see we have 10 minutes left, and I leave this to questions. Thank you.
Thank you, Hassan, for sharing those things. It's really important first to highlight the the issue using the data, and then um, um, help us understand that data through explanation. And then, of course, the final point is what can be done to prevent these climate situations and all that. And thank you for highlighting those. So first, I have one single question from my side, and then I will ask other speakers who have posted their questions in the chat if they could ask themselves. My question is that regarding the bricolage, I heard about some kind of the technology intervention called zigzag technology, which government officials told that this technology reduces emissions from brick kilns. Can your model by somehow identify the emissions from any specific brick kiln so that we can differentiate between those that use this technology or not? So that instead of closing down those brick kilns, we can move to some good measures which can prevent people's livelihood and also uh, 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 can help us address this climate issue.
Sure. I can answer that, and in case someone wants to jump in later on. So we've already done that. We have identified the fixed chimney brick kilns from zigzag kilns, and the data set that we've produced already gives that distinction. But what it doesn't give, it gives us the location, but what it doesn't give is the operational time, right? So the satellite imagery cannot tell you um, the number of hours it's operating. So we've done ballpark estimations for emissions based on, okay, it's operating on an 8 hour day or a 10-hour day seasonally, and we've given those numbers. But we have a data set. I think someone can share the link. Maybe Khizar, if you want to share the Zenodo link for the data set and people can have play with it. It's a CSV file. So it's simple and you can just open it in GIS.
Okay, for we have a question from Alia. So Alia, if you are here and could ask the question yourself.
I don't think
Okay.
Ali.
So let me read it. What are the main sources of poor air quality shown in the previous images and that were shown by the first presenter? And what are we specifically looking at? Are we focusing on a particular source or not? I think partially this question has been answered in upcoming presentations, but still, if someone would like to respond to.
Khizar,
Yeah,
I think that question's
I think the image I used shows the formaldehyde polluting gas. That's one of the pollutants. So the purpose of showing that image was the hotspot zones, across the IGP region, as you can see in that image, like, the red part sort of highlights the IGP region that we are focusing on, and also how bad the air quality is there. So I think I already answered in the chat. I already wrote down the answer as well, that the pollutant is formaldehyde, and then the light color represents that lower concentration of that particular pollutant, and their hot colors, the red colors, sort of represents the higher concentration present in across the spatial um area that been presented in the map.
Okay, so thank you. Next question is from Dr. Maruf, and Dr. Maruf, if you could please ask your question yourself. Unmute yourself and ask this question, please. Okay, so let me read the question posted by her. Does this spatial and temporal technology is also capable to identify coal burning in furnaces, power plants, and other fossil fuels being used in the industry?
Again, thank you for the question. What we are able to identify is we can identify the assets, and we have done so for power plants and other fossil fuels. But what it does not tell us is the emissions that's coming from it. So for that, we do assume certain estimations, and we use production capacity, for example, as a proxy, and then academic literature estimations to give a number. It's more good at spatial context, but temporally, it's more of an estimation.
Yeah, and for the emission, I think the high split model can do only much, like, you can it's also based on assumption, and it's also hard to tell temporally because it's based on archive data from the meteorology, and then depending on the quality of all the data that we use. So it's just an estimation and a number that you can get, but the satellite cannot do that.
Okay, thank you. Now, may I invite Mr. Rizwan to ask his question himself?
And thank you so much for a wonderful presentation. As it is mentioned, it's a cross-border issue. Are you aware of any collaboration happening between Pakistan and India? I know that it's not a right time to ask this question, but is there happening in Pakistan in any strategies or research-based thing?
Yeah, so we are doing that. There hasn't been any collaboration in terms of, I would say, at government or at state level. But at APAD, what we're doing is engaging with research organizations and other air quality initiatives in India and Bangladesh. And the idea is to share research insights, but also share data and understand the problem better specifically at the border, at the Punjab Sindh border with India. So for that, we are aiming to also expand the APAD citizen science app concept to identify unregulated sites.
Okay,
Then there's
so
another question.
Zishan, can you please unmute yourself and ask question?
He wants you to read it.
Zishan has
So,
asked us to read it.
okay,
So I've
okay.
read. So I can just answer. So the question's more on major sources of air pollution in Pakistan, and can you show the regional distribution of air pollution in the country? Um, Again, major sources of air pollution varies spatially and temporally. On certain times of the year, or at certain times of the day, the sources differ. So it depends on where in Pakistan you are. But of course, to put it into context, vehicular pollution or other fossil fuel used energy sources are one of the major sources that we experience. And then again, the conversation on regional distribution, it varies. It varies spatially. There are certain academic literature that looks into it, and I can point you if you are interested.
Okay, so next question is that from the Huri, this is that what steps can we take to move towards cleaner energy generation like solar and nuclear?
What steps could look like again? What steps? I mean, where do we start? We already do have lots of clean energy coming from nuclear, coming from solar, coming from hydropower. Um, it depends on the government financing more solar energy. It's something that the state needs to have a more national policy on, subsidizing solar power, for example, and how we can have more off-grid solar panels, etc. But that's a different question. That's an energy transition question. But of course, that would help us reduce some of our emissions coming from coal power plants.
Okay, Hassan, since you have talked about state and its intervention, yes, it's in the hand of that. But I was just thinking about a common question that is usually asked in Pakistan or and commonly highlighted point. Again, your choice if you would like to respond to that or not, but it's more in the political, economic, or economic sense. So one of the argument, which is very popular in our part of the world, and especially in Pakistan, is that the South Asian countries, and particularly Pakistan, are not much responsible for this climate issue. And since our share is also low, therefore, we can, even if we control it, it will not make much difference to the global environment and global impact. And even for controlling it, there is a lot of cost that we have to make. And given the economic conditions of these countries, it's quite difficult for them to finance those things. So the policymakers tend to put this as an excuse not to react. But if you could tell us something about it, how some counter argument or something like that.
Yeah, I mean, Pakistan currently does one. I would first want to address the part where you've mentioned that how Pakistan does not contribute a lot to carbon emissions. Considering even if we do not contribute to carbon emissions on on an absolute level, we still do emit a lot of greenhouse gas emissions. And the question for Pakistan is that, okay, if we do need to transition to a cleaner energy, we would have benefits that go beyond just your economic benefits. You do have health benefits and social benefits that come along with it. In terms of financing clean energy transition, there have been what's difficult is the ones that have been financed by Chinese lenders. But there have been cases if you look into South Africa and Indonesia, and specifically the Just Energy Transition Partnership, which is JETP, it does allow you to, it does uh, allow a sovereign body like Pakistan or to have an exit strategy for the coal power plants that have been financed by Chinese banks and lenders. So, I mean, these are excuses that Pakistan government gives, and there are, of course, some of the contracts are much more binding than the others, and Pakistan, I think, has been trying to come out of those IPPs quite recently, and the current finance minister is trying to do that. So, yeah, I mean, Pakistan expected that we would have a humongous growth in the next 10 years, and we will use all of that for manufacturing, and we're not using any of that. So there are two ways. Either we start, investing in, coming back to our manufacturing, or we try to renegotiate the contracts.
Okay. So one more question from Dr. Maruk. She asked if local or international funding comes to you for air pollution, which technology you would prefer to invest to solve the air pollution in the context of Pakistan. And I guess by you, she means the decision maker. if you are at
Yeah.
that position, maybe.
Again, it depends on the readiness of the technology and the impact it would have. Considering there's been a lot of work that's been done in energy, there would be little local or international funding. Probably, I don't know if that counts in clean energy in terms of transport. But there could be uh, things you can have interventions in e-mobility, um, which you can have electric mobility bicycles for short commutes. There's a lot of funding that goes to Africa and India in terms of low cost and clean energy cooking stoves, and this is something that's missing from Pakistan. So maybe if you're looking for funding and you're applying for grants, maybe positioning your proposal more on cook stoves can bring in funding, and so that would reduce indoor air pollution exposure for women. That's the case you can make.
Yeah. Okay. So I think let me wait for a minute. Dr. Maruk seems to be writing her question, maybe. So if that is not, we have addressed all of the questions, and mm, just let's wait for 1 minute if she could complete this and post.
So Zishan has basically re-asked his previous question on whether the air pollution is more related to economically developed areas or if it is unrelated. Again, there has been research outside Pakistan that points into how socio-economically deprived areas do tend to face high exposure levels for air pollution. But again, I've not come across literature with the Pakistani context, but the hypothesis would be that certain economically less developed areas would have higher rates of exposure. But again, when Pakistan faces, or specifically the IGP region faces blanket episodes of high pollution levels, what happens is that it's everywhere. It's the same everywhere, and you'll have very little variation across certain neighborhoods, if there are any variations that happen.
Okay, okay. Thank you, Hassan. And let me just put something from my end in and combine it with Dr. Maruf's question. How about city designs? Modern cities are more horizontal than vertical, and there are some alternate commutes like walking tracks, cycling, and other such facilities. But in Pakistan, we see our cities have sprawled so much. And we do not see much high-rise buildings, and that makes us to travel a lots of kilometers daily just to commute to our offices or to universities and getting back to home. So, how do you think this shift from these badly designed cities to more modern structured cities can help us address climate issues?
um, Again, on that, Pakistan, as in the lots of our urban centers were made walkable. If you go back to Rawalpindi, you go back to Faisalabad, you go to Multan, you go to Lahore, Karachi, Sadr, all these cities were actually walkable. And the recent urbanization model of building highways within the cities and building 4-lane roads is not development. So the current infrastructure does not actually encourage cycling or walking. There are rarely any pedestrians you'd find on the footpaths. Rarely even in Islamabad, which is thought to be pedestrian friendly, but then again you'll come to a junction or you come to a road where you won't have a footpath sometimes, or if you have to cross a junction. So I mean, there's so much to do in terms of urban planning, and we need to rethink how our cities were built actually. And they were much more efficient initially, and we just made them less efficient in terms of how commuting is done.
Okay, okay. Thank you. Thank you for this. And with this, I'm really thankful to Hassan, Iman, Suleman, Khizr for their insightful sharings, very useful data points, very insightful explanations, and at the end, some sound policy recommendations and really some good food for thought for all of us. So with this, I'm also very much thankful to all of our participants who joined us and posted their questions and engaged in this discussion. Please visit www.prisa.org.uk for more for the information on more such events and to see our work which we are doing in context of South Asia. And we shall post this recording on our YouTube channel, so do visit that as well. And with this, and again, with a thanks note to the speakers and participants, I call this session off today. And so take care, everyone. Thank you and goodbye.
Thanks, everyone. Thanks, Iman, Suleman, and Khizr. Thank you. Bye.